Let's go ahead and talk about tangent. So now we want to find and create our inverse tangent function. But as it stands, if you look at the graph here of tangent, it is not one-to-one because if I drew a horizontal line, it would intersect the graph of the function at multiple locations. So what we need to do is we need to restrict our domain and make our new restricted domain negative pi over 2 to positive pi over 2. And if we do that, between those two vertical asymptotes, we have a one-to-one function, and we can create our inverse function. Now, the inverse function is the solid blue curve here, and notice that it is bounded for its y values up above by pi over 2, and it's bounded below by negative pi over 2. So the inverse tangent function is the function tan inverse with domain. This fancy looking r means all real numbers, or we could put the interval negative infinity to positive infinity, and range negative pi over 2 comma positive pi over 2 defined by tan inverse of x is equal to y if and only if tangent of y is equal to x. Sometimes you will hear this called arctangent and written arctan for short. We have the following cancellation properties. Tangent of tangent inverse of x is equal to x for all x in the real numbers. And tangent inverse of tangent of x is equal to x for all x between negative pi over 2 and pi over 2. You will find this helpful when solving for angles within functions, but also when looking at domain and range restrictions. Example 3 asks us to evaluate the following expressions. First, we want to take tan inverse of 1, and we know that this is equal to some angle theta, and the 1 here represents a length or a ratio of lengths. And so if we're thinking about the unit circle, another way that you can think about tangent is it's the slope of the line segment. So we want to know where the slope is equal to 1, and that's happening on the line y equals x. And so the coordinates for this terminal point are root 2 over 2 comma root 2 over 2. Since the x and the y value are the same, that's what gives us a tangent value of 1. This is our x coordinate, this is our y coordinate, and just as a reminder, tangent of some angle is equal to the y coordinate divided by the x coordinate, or another way of thinking about that is sine of theta divided by cosine of theta. So in this particular example, we have root 2 over 2 divided by root 2 over 2, and that ends up equaling 1. So the angle that ends up giving this to us is pi over 4. So you could present your answer as pi over 4 or 45 degrees, whichever you prefer. Now, tangent inverse of 30. 30 is not one of our unit circle values, so we're actually going to need to utilize our calculator here. So I'm going to make sure that my calculator is in degrees, and then I'm going to hit secant tangent, and then enter in the number 30, and press enter. So we find that tangent inverse of 30 is, I'm going to round it to 88.1 degrees. And that is our answer. And another way of saying that is that if you take tangent of 88.1 degrees, it's going to equal 30 or close to 30 since we rounded the angle. Okay, so part C wants us to evaluate tangent inverse of negative root 3 over 3. And it might seem like we need a calculator for this one, but we actually don't because negative root 3 over 3 is one of our unit circle values. So negative root 3 over 3 is the same thing as negative 1 over the square root of 3. And that is the same thing as negative 1/2 over root 3 over 2 because that is equal to negative 1/2 times 2 over root 3. And the 2's that end up canceling out, and so that's how we get that. So we are looking on our unit circle, and you might be asking the question, how did I know the 1/2 was the negative value instead of the negative root 3 over 2 being the negative value? And the reason that I knew that is because tangent inverse falls either in the first or fourth quadrant, because we know that the range of tangent inverse is between negative pi over 2 and positive pi over 2. So this is the y value and this is the x value. So I'm looking for a terminal point where the y value is root 3 over 2 and the x value is root 3 over 2 and the y value is negative 1/2. And the angle that gives that to us is negative pi over 6 or negative 30 degrees. So either way you want to give your answer, either of those is fine. And that's how we accomplish part C. All right, part D wants us to find tangent inverse of sine of 11 pi over 4. So I'm going to erase some of this to give me some room here. Now on the unit circle, 11 pi over 4 is coterminal with, let's see, because I have 11 pi over 4, I can subtract off a full rotation, which would be 8 pi over 4, since that is equal to, since this whole fraction is equal to 2 pi. So if we subtract off a full rotation, that ends up giving us 3 pi over 4, and 3 pi over 4 is in quadrant 2. So that's 3 pi over 4. And then what's going to help us out is this angle here, which is our reference angle, pi over 4. So I know that the coordinates for this are negative root 2 over 2, comma root 2 over 2. And the sine value is the y value. So this is going to be equal to tangent inverse of root 2 over 2. Now, you might be thinking to yourself, oh, root 2 over 2 seems like a common unit circle value. And it is if you're talking about cosine or sine, but tangent inverse of root 2 over 2, that's going to require us to use our calculator. So I'm going to go ahead and punch that in, tangent inverse of the square root of 2 divided by 2. And remember that this is in degrees, so I'm going to round it to the nearest tenths place. So this is equal to 35.3 degrees. And that is my final answer for part D. All right. Last part for this example, cosine of tangent inverse of negative square root of 3. It might not seem immediately clear, but negative square root of 3 is one of the common unit circle values because negative root 3, we get that from getting negative root 3 over 2 divided by 1/2. And again, I know that the y value, since tangent is y divided by x, I know that the negative 3/2 is negative root 3 over 2 is the negative value on our unit circle, because tangent inverse has to fall either in quadrant 1 or quadrant 4. So if our angle is negative, then we know that the y value has to be negative. Okay, so we're looking for an angle such that the y value is negative root 3 over 2 and the x value is 1/2, and that angle is negative 60 degrees, or negative pi over 3. So now we're looking for the cosine value of that, and we have it graphed here, and cosine is the x value. So cosine of negative 60 degrees is equal to 1/2. And that concludes this example. In order to define the inverse functions of secant, cosecant, and cotangent functions, we restrict the domain as follows. These choices simplify the computation involving inverses and are used in calculus as well. So notice here that the range for arctangent is between 0 and pi. So for arctangent, the range is going to be between 0 and pi. And so that's why in the cotangent graph, we are restricting the domain between 0 and pi. So we're ignoring everything outside of that so that we can get it to be a one-to-one function. And then if you look at these ones, the range of secant inverse is going to be 0 to pi over 2, excluding pi over 2, union pi over 2 to pi brackets. And then for cosecant inverse, our range, as we can see from the graph, is negative pi over 2 to 0, union 0 to pi over 2. So this helps us think about the inverse trig functions.